So in this video I want to share with you my idea of a retractable and extendable helical antenna that I came up with purely by accident and purely due to the fact that I was searching on the internet to try and find a new lampshade for my floor lamp. Now unfortunately you can't buy the shades on their own, so I've got to buy a complete new lamp, but you know, it's a bit of a waste. But to be perfectly honest, this is how I came up with this idea for a concept of a retractable and extendable helical antenna. So at the moment it's fully extended, but if I press this button here it will retract, so it has a much smaller footprint. And of course if I want to extend it I can just press the other button. Now this is the only one that I've actually made, so it's just a concept idea. The video itself is just me hacking along the way, coming up with ideas as I put it all together, so hopefully you'll find it enjoyable, and as I'll show you at the test at the end, it actually performs quite well. So I'm going to try and create a helical antenna for 2.4 gigahertz using a similar kind of construction method that they've actually used to create that shade for the floor lamp. So for the element for the helical then, I've got this copper wire. It's 21 SWG, so it's quite thin, so it should be flexible every time you extend and retract the antenna. Now I've got some flexible stitchable fabric glue here. Now there's different kinds of fabric glues, but this one apparently dries like rubber, so you know, it'll be flexible when you're extending and retracting that helical antenna there, so hopefully that should work out fine. And instead of using paper like they have done in that lampshade, I'm going to use some cloth. So this is quite thin cotton cloth, and what I'm going to do, I'm going to put a layer of that on my tube first, and then wrap the helical antenna around here with the copper wire, and then put another layer of the cotton material over the top, sandwich it all together using this glue, and hopefully when it dries then I should have a helical antenna that's the correct diameter, and it should be flexible when I concertina it up and then extend it out again as an antenna. Well, that's the plan anyway. Hopefully it should work. And to make sure that when the glue's dry it just doesn't all stick to my tubing here, I've got some cling film, and I'll put a wrap of that around first before I actually start building up the layers of the cotton, the copper, and then cotton on top again. So I'm going to start wrapping the windings round. Now what I've done to actually help me and keep tension on the wire itself as I wrap it around to get all the kinks out, I've drilled a small hole here on the edge of the tubing and just put the copper wire through there, and once I've got them all wound I can just simply cut this then to release it so I can take all this sleeve off. But a little hole there just helps me to keep tension on it while I wrap all the coils around. So I'm going to start wrapping the coils around here, keeping it quite tight just with my finger and thumb. It's quite thin copper wire this, so a little bit of tension should get most of the kinks out of it. So I'm just taking my time and wrapping the coils, moving the plastic tubing around to wrap those coils around. And once I've got a few on there, I'll get the ruler out and manoeuvre them to try and get them in that 30mm spacing. So now that I've got about 6 turns on here, what I've actually done is I've just stopped, got my ruler and just checked that I've got it round about in that 30mm spacing that we need, just so I can actually manoeuvre them a little bit towards the end, because you don't want them to be way out, because once you've got them all lined up down the pole it's going to be much harder to get them all lined up to that 30mm gap if say this one is a 50mm gap. So you want to get it in that ballpark, and any small changes you can do at the end then. So I've got the coils spaced out and as even as I can get them just using my eye and the ruler without a template, but I'm happy with them now. So what I'm going to do is cover all of this with a layer of the fabric glue, and then I'm going to put another layer of the material over the top of this, and what I'm hoping is that the glue will set and the copper wire will be laminated in between the two pieces of material, so it won't move from these positions, but it'll still be flexible enough to extend out and then concertina back in on itself. So I've decided to spread the glue around one half of the tubing itself first, get the glue spread out, and then wrap the actual material around this half, then turn it the other way around, spread the glue on the second half, and then complete the wrap, and hopefully we should have a nice laminate between the actual cotton material and the copper inside, and the copper won't move. So I did try to cover half of the tube with the adhesive, as I said I was going to do, but I got into a bit of a mess. So I'm trying again, and this time I've covered all the tube with the adhesive, so you can see how much I've actually used there. Hopefully I'm not using too much, but I do want to get a good connection between the two halves of material to actually laminate and hold those copper windings in place so they don't slip or move about. So this time I'm going to roll it all up, just slowly rolling it over the top of the material, just taking up any slack and flattening it down as I go along. So I've got that top layer in place now, and the glue has saturated that top layer, so I'm hoping I'm now going to get a good laminate between the top and the bottom, and it'll do a good job of holding those coils in place. So what I'm going to do now is leave it for 24 hours just to actually set, and hopefully it'll come off this tube no problems at all with that cling film that I first put on as well. So we're back again after 3 days. I did leave this to dry for 3 days, and I did have my doubts when I was applying the glue whether it'd be strong enough to hold the copper coils in place with the material sandwiched in between, and I have found that although it's dried, it's just not strong enough to hold these copper wires, the copper coils, in place with just that fabric glue. So what I've actually done now, I've got some solid core wire that I've got here in the lab, and I've wired 2 coils of the solid core wire around the helical, sandwiching it in between the material here like this. So what I'm doing now is actually applying a little bit of super glue down in that trench on top of the wire, and what I'm hoping is, even though the super glue dries rigid, because it's just in the area where the copper coils are, it will be strong enough to hold it in place, and also I'll still be able to extend and then contract this as a whole, but definitely the fabric glue is not strong enough to hold these coils in place. Now I did also think about actually sewing the copper coils in place directly to the material, but that's another option, but I'd have to start from scratch again. So I'm going to do this little super glue technique all down the coils, let it dry for a good couple of hours, and see how well that does at holding the coils in place. So the method of using super glue is working out a lot better. As you can see there, I've got this nice ridge either side of each of the copper coils, and the wire is actually coming away quite easily. I was worried that it, you know, using super glue, it might have been held down there too much and rip itself away from the material, but it's doing a really good job, and you can see that I've now got ridges there, and because it's super glue, I don't think the copper coils are actually going to come away from the material, so this is probably a much better way of actually doing it. So I've managed to get it off the tube in one piece, and it was a little bit of a struggle. I think what I'd do next time is put some silicone grease on the tube and then wrap the cling film around, and then apply the 2 pieces of cloth and all the glue. I think that'll make it a little bit easier to get it off the tube next time. So this is the automatic car aerial that I purchased off eBay. There are quite a few Chinese sellers selling these. They all seem to be about the same. I paid about £14 for this with free shipping from China, and to be quite honest, I'm not going to do a great deal of modification to this at all. You've got your power lines here for your positive and your negative, and this green wire, when it's actually shorted out to the positive, the aerial extends, and when you remove this from the positive, then it retracts again. So it's pretty simple. I think probably all I'm going to do is try and get rid of some of this hardware on the end here to try and make it a little bit more streamlined, but apart from that, I'm not really going to modify anything in this at all. So what I've decided to do is to fit everything inside this large project box that I've got here. So I've cut a space in the side here so I can fit the automatic aerial through here, and I'm going to run the aerial itself off this small 12-volt battery. So using this project box, I should be able to fit everything inside here, all the switches and everything that are going to operate the automatic aerial for it to actually extend and then retract again. And I've put a small thread on the base here just so I can attach everything to a tripod when it's finished. Now for the reflector for the helical, what I've got here is a plasterer's hawk. This is actually aluminium sheet, and I only paid about £8 for this from a local hardware shop that's close to me, but you can pick these up off eBay even cheaper than that. So what I'm going to have to do is make this hole a little bit bigger so I can fit the automatic aerial through, and also work out where to drill a smaller hole so I can actually connect to the helical antenna itself. So I've attached the reflector to the side of the project box here, and I just attached it with 2 bolts drilled all the way straight through onto the reflector and the project box. I did come a little bit close to this pillar here, but it's doing a good job of holding it in place. I also ground away the bottom part of this pillar here just to get it up flush against the side wall of the project box, just so there's a little bit more room inside. So if we take a quick look at the automatic aerial case here, I want to actually butt this up flat to the reflector. So I want to remove this screw and the plastic and ground it down flat. Now I don't think it's going to do any detrimental effect to how this actually operates. I think these screws are positioned in a way to hold the unit together and also keep out water. So I don't think keeping out water is going to be an issue with this build. So I'm going to remove this and ground it down flat just so I can actually butt it up flush against this side wall here. So next I'm going to have to work out how I'm actually going to connect to this helical antenna. So I'm going to need to connect it at this point here, but I'm also going to need a metal shim to bring the impedance down to 50 ohms. Now Jason's blog post says that we need a metal shim that's 17 millimeters by 71 millimeters. So I've got some copper tape here, and I'm going to place it around here like so and solder it onto the helical itself, the copper wire that's under here. So what I'm going to do is expose the copper wire in this position here. I'm also going to glue this piece of tubing in here just on the inside there to actually help support this small piece here where I'm going to be attaching the copper tape, just so that this doesn't actually compress down. It just stays rigid like that, just to make sure that we don't damage the copper tape here, or actually damage the connection that we're going to have to make here to the copper wire. So I'm going to get the Dremel tool and very carefully ground off the material that we've got here to expose the copper wire, and then stick the copper tape down and flow some solder in there as well, just to make sure we've got a good joint with the copper shim there, and hopefully I can solder onto this position here. Well, that's the plan anyway. So that's the copper shim soldered in place to bring the impedance down to match the 50 ohms of the coax. Now what I'm actually going to do to blend this in is just put a little bit of black spray paint on here just to blend it in with the rest of the helical, but I'm going to put a little bit of masking tape on the end here because this is where I'm actually going to solder onto so we can connect to the helical antenna. So to connect to the helical antenna, what I'm going to use is this very short pigtail. I've got an SMA connector on this end, so I can actually attach a Wi-Fi card, or even if you're wanting to use this for FPV, you can attach a receiver on that side. But I'm going to modify this bulkhead connector, the SMA bulkhead connector here, so I can actually solder this directly to the helical antenna. Now, because my reflector is made out of aluminium, I can't solder to that, so I'm going to need to use a bulkhead connector. Now, this I'm going to actually modify slightly. I'm going to cut it down here and solder the helical directly onto the center pin of this SMA connector. So here's the modified SMA bulkhead connector, and what I'm going to do now, I'm just going to mount it on the reflector to see how it actually sits, and I may cut away a little bit more of this dielectric here and solder directly onto that center pin. So the bulkhead connector is fitted in place. I'm really pleased how flush that's actually sat on there now. So what we can do, we've got a good connection to ground on the reflector with the bulkhead connector nut here, and we can also solder our helical coil directly to that center pin there, so we've got a good connection there as well. And as I said, I'll probably just trim away a little bit of that dielectric, just leave a little bit in place so we have that little bit of insulation between the ground plane and the signal center pin there. Now, as I said previously, I'm going to be running this off this small 12-volt battery, but I just wanted to quickly show you how this automatic aerial here actually extends and then retracts back. So at the moment then, I've got the negative and the red positive connected directly to the battery, and nothing's actually happening at the moment. Now, to actually get this to extend, what you need to do is actually connect this green wire also to the positive on the battery, and that way then it will start to extend out. Now, if you actually want this to retract now, what you have to do is now remove this green wire, and then it will retract inwards. So that's the way this automatic car aerial works. So what I'm actually going to do, I'm going to rig up a couple of push to make switches to actually push in manually like a dead man switch, and when it's extended I can release. And what I'm going to do differently to stop it from retracting back, I'm going to cut all power to the battery so it still remains extended, and then when I want to retract it in, I'm going to push the push to make switch again, which will just connect the red wire and the ground wire here, and then it should retract in on itself, and that way I don't have to keep the 12-volt battery permanently connected to the antenna itself to stop it from actually retracting back in. So I've epoxied the aerial into the project box. I epoxied underneath there and I just left it overnight. Hopefully that'll do a good job of holding it in place, but I just wanted to quickly go over the wiring again, how you actually operate this automatic car aerial. So these switches only actually work when you apply pressure. As soon as you release them, they actually turn off. So these are actually going to be perfect for operating this aerial and making it a little bit more simplified. Now, I don't want to permanently connect the power from the battery to the car aerial itself, and normally if you're installing this in a car, that's what would happen, and I don't actually want to do that. So I've got the two push to make switches here. So the antenna, the car aerial actually extends when you've got the positive and the green wire on the positive on the battery. So when those two are connected, the aerial will extend. So what I can do is push these two switches at the same time, and I can extend the aerial. Now, because I've released the 12 volts isn't going to the car aerial now, so it's just stayed in that one position. So what I can do now to actually retract that aerial is just press the red button here on its own, and then it'll retract. And that's the simplest way I could come up with to actually get this to operate. So now I want to connect the helical itself to this part of the reflector here. I want to connect it permanently down here and also solder it onto this pin here. So what I've got here is a small rubber stopper, and I ground off, it had like ridges around the sides here, and I've drilled a hole through the center so the diameter is wide enough to actually fit over this part of the aerial itself, the automatic aerial. And what I'm going to do is, when I get it into position here, I'm going to put epoxy putty down into it here. So I'm essentially going to pot it around the metal tube here. Now, epoxy is a really strong glue and I use it all the time, but it does need quite a large surface area in order for it to be strong. If I just glued the helical here using the material, for instance, to this part of the reflector, it would eventually fail in this area because it hasn't got a big surface area in order for it to make contact. So hopefully when I epoxy this in place, it's not going to move anywhere anytime soon, and I can just put epoxy around inside here then, and I can feed that over the top of that rubber stopper. Then we've got a good surface area of grip for the helical itself. We can solder it onto that pin there, and it's not going to rip out when we extend the antenna itself. So to finish off the end of the helical antenna then, so we can actually extend it and then retract it back in, I've made this little stopper here out of some plastic tube in the same diameter that I use to actually make the helical antenna. It's 42mm in diameter. I've capped off the end with some thin cork matting, and you can use plastic, something like that, just make sure it's not metal. And I've basically attached that to the end of the aerial and just potted the entire thing in there with epoxy, so it's not going to come off anytime soon, because it does will take a lot of stress, this a little bit of strength, to actually retract the helical antenna and then extend it as well. So I've potted it in there so it's nice and strong. So what I'm going to do now is a little bit of epoxy around the sides of this and then attach it to the helical just like I did at the feed point. So to actually connect to this then, I'm going to use a Wi-Fi card because it's much easier for me. You could easily add a receiver for FPV if you wanted to, but I've just got it connected here with the SMA connection, and I've made this short pigtail of USB cable, if you will, and I've cut a hole in the side of the project case, so I'll epoxy this to the actual case itself, and I can just connect an extension cable on there just to actually power the USB card and actually use the USB card, and the 12-volt battery will just be there just to power the actual aerial itself, the car aerial, for actually extending the antenna and then retracting the antenna. So I'm having a second go at actually making the helical for this antenna. Now I've got this one fitted on here, and while it extends out quite well, I'm not happy how it actually folds back up again, because I've used that rubber fabric glue. It is quite rigid, so the actual automatic aerial is having a hard time actually folding it back up, and the only way I can get it to fold up quite neatly is to guide it with my hand. So I'm having another go at making the helical antenna, but this time I'm not going to cover it all in that rubber fabric grill. What I've done is I've put the copper wire here in the helical shape, and I've got the first piece of cloth underneath that. I've just gone round and drizzled the super glue on top of the copper windings here, so it's adhered to that first layer of cloth. So I'm going to now cover it in the second layer of cloth, and I'm going to do the same again with the super glue method of drizzling it on like I did with this one. So I'm not going to cover it in that fabric rubber glue, and hopefully it'll actually fold up a lot neater than it is doing at the moment. So I'm quite happy with this second helical. It actually folds in a lot easier now, and I haven't put any cotton over the top to sandwich it in between. The super glue is doing a pretty good job of holding those helical turns in place, and because we've got no glue in this area here, it does actually fold up a lot nicer than the first one anyway. So I'm just ready to actually give it a quick test so we can see how well it actually performs, and I've put this plastic handle on here that I had lying around in my parts bin, so I can now pick it up quite easily, and that's the helical retractor. It's still a little bit messy, but it's actually retracting a lot easier than the previous one. So let's give it a bit of a test then and see how well it actually performs. So let's give it a quick test then, and I can't get it up against my window like I normally do, so I've got it here on the bench, and it's actually got to get through the brick wall there in front of it. So if it actually turns up about 25 to 30 access points, I'll be very pleased with the performance of this. So it's loaded up quite a few access points there, and there's plenty of green ones, and some of those actual percentages are quite high, so I'm pretty pleased how this is performing, especially as it's got to cut through that brick wall first. So as a concept then, if I spent a little bit more time on this, maybe I could come up with something a little bit better and not quite looking like it's thrown together, but for a first try it's actually working really well. So I hope you enjoyed this little video on my concept of a folding helical antenna, and sometimes, you know, it's really rewarding to just get an idea in your head and then actually just get some materials in front of you and just start building it from scratch. But I'm pretty sure if I put some more time into this and a little bit more thought on the materials I'm going to use, I could probably polish this up and you know, have a really good practical working folding helical antenna. So any questions or comments, drop them below, and any suggestions that you think I could use different materials to actually improve this design. But it does actually work well as an antenna. It's a 27 turn helical antenna, so it's quite long, a lot longer than what I would normally use anyway. But definitely having that folding action to retract it back does make it a much more practical design. So if you did enjoy the video, please give it a thumbs up, and hopefully you'll join me on the next one.